The lesson topic for this video is graphing radical functions with a table. Okay, so as we start this topic of radical functions, we for sure need to know what a radical is. So a radical is, well, for example, a square root. Now there are also things called third roots and fourth roots, etc. And you will learn about those in the future, but we're not going to talk about third and fourth roots in nonlinear algebra. We're going to talk about square roots. So if you think about, there could be a little 2 right here for a square root. We just don't write it in, kind of like when we have x and we don't write 1 in front of it for 1x. Same kind of situation there. So we'll erase that 2 because we don't need it written in there. It's still a square root. So let's remember what a square root means. A square root means that whatever number is in here, what number multiplied by itself gives us that number. So we could write something like square root of 16. So the question is, what number, when multiplied by itself, gives us 16? And the answer to that is 4. Okay, now one little note here. What we're actually asking for when we look at this square root of 16 is we're actually asking for what's called the principal square root of 16 or the positive square root of 16. And so that is 4. And I say that because if you think about how another number that multiplied by itself gives you 16 is negative 4. So think about that for a second. I'll go off to the side with a different color here. So if you think about negative 4 times negative 4, we know a negative times a negative is a positive. So this answer is positive 16. So you might be thinking there's another option for what number times itself is 16. But when we have just a square root of 16 like this, we're asking for the positive square root answer, or the principal square root. So the square root of 16 is 4 because 4 times 4 is 16. So let's just talk about a few of these. So what we're looking for if we want to list a bunch of square roots that come out as whole numbers is we're looking for numbers that are perfect squares. So we know the square root of 1 is, well, 1 times 1. So the square root of 1 is 1. Square root of, well, 4. Well, the square root of 4, what number times itself is 4? Well, the answer there is 2. 2 times 2 is 4. Square root of, I'm not going to write a 5 in there because there's not a number multiplied by itself to give you 5 or 6 or 7 or 8. But once we get to 9, we realize there is a number multiplied by itself that gives us 9, and that is 3. So what we're looking at in our roots here is our perfect squares help us get whole number results when we are taking the square root. Okay, so we're going to have square roots, obviously, in our square root function. And here is what the general standard form of a square root function looks like. It's y equals a times the square root of x minus h plus k. Now we're going to get way more into what all of these a, h, and k tell us, just like we did with our exponential functions. We were looking at what does a and b and our x and y values tell us. Well, we're going to do the same thing with square root functions, but we're not going to do that yet. We'll get into that as we go. But for right now, just know that if, I'll give you an example here. So for example, y equals 3 times the square root of x minus 2 plus 7. Okay, that would be a square root function. Our a value is 3, our h value is 2, and our k value is 7. So we'll talk more about those pieces as we go. But for right now, we're going to look at a table of values, and we're going to graph what's called the parent function of a square root function. And that is kind of like our base function for square roots. All right, so here is the parent function for our square root function. It is y equals the square root of x. Now, just like we did for linear functions and exponential functions, we can graph using a table. So we're going to do that right now to see what the curve, it's a curve, that the square root of x produces for this function. So let's start by putting in a 0 for x. And typically that's sometimes what we do. So when we put a 0 in here for x, we have to think about what's the square root of 0, and the square root of 0 is 0. So 0, 0 is our first point. Now, what if we put in a 1? Well, then we take the square root of 1, which we know is 1, because 1 times 1 is 1. Now, if we put in a 2 next, that would make us have here that y equals the square root of 2. Well, that's fine, but the value when you take the square root of 2 is actually 1.414. That's totally fine. We can plot that on our coordinate plane, no problem. But why don't we try to stick with good, helpful x values to get whole number y values? So that means we're going to think back to those perfect squares we talked about on the previous screen. What number goes in here nicely? The next number, not 2, not 3, but 4, because the square root of 4 is 2. The next one we had on the previous screen was 9. If we put 9 in, the square root of 9 is 3. Now, what would happen if we put in -1? Because a lot of times we'll say, let's also put in a negative value for x and see what happens. What happens when we put in a -1 for x? Well, let me go off to the side over here. If we put in a -1 for x, we now have the square root of -1. Well, remember, what that means is what number times itself is -1. And if you're thinking, well, there isn't one, you're actually correct. We know 1 times 1 is +1. And so you might be thinking, oh, negative. But if we put -1 times itself, well, -1 times -1 is also +1. There is no number when it multiplies by itself that gives us -1. Okay, so that will never, in this function, will never work. A negative value will not work, which means our domain, remember our domain is our values for x, is restricted to only positive values. Okay, so now let's graph these points. Okay, so our first point that we're going to plot here is 0, 0. And I'm going to use a larger dot here to make it work nicely there. So there's 0, 0. And then we have 1, 1. And then 4, 2. And then we have 9, 3. And again, because we found out that no values of x can be negative, because then we know that that is going to be the square root of a negative, which does not work. We know that the curve can't go to the left of the y-axis, no x values over here. And so it is just going to be a curve that goes like this. And that is our parent function for the square root of x. All right. One quick note about the square root of -1, by the way. So mathematicians long ago decided that since there's a square root of -1 right there, and it doesn't give us a real value, a real whole or a real value, we'll say, they actually named this I, and it's usually a cursive lowercase I, and that is part of our what's called the imaginary number system. So more on that in future math lessons, not in this unit though. Okay, so for this example, this is not the parent function any longer. This is a square root function, y equals the square root of x minus 1 plus 3. Now, important note, notice that the root ends right here, which means the plus 3 is not inside the square root. So we would do the math in here first, kind of like our order of operations. It's kind of like we treat this like parentheses, like we would do that first inside the parentheses. So we do this first, then we're going to square root it, and then we're going to add 3. Now, notice if I put in a 0 for x in this problem, a 0, I'd get 0 minus 1, which is -1, and we can't take the square root of -1. So we're going to start this off with our domain restricted to 1 or greater. Our domain, again, is our x values. And I'm going to actually just give you the x values to use to give us some nice, easy outputs, whole number outputs. And then we're going to plot the points and graph the curve. All right, so if we put a 1 in for x right here, put a 1 in, what's 1 minus 1? Well, 0. The square root of 0 is 0 plus 3. So that is 3. Why don't you go ahead and plug in the rest of the values, 2, 5, and 10 in for x and find the corresponding outputs, and then check back to see if you got those values correct. Okay, so you should have put in 2 next for x. 2 minus 1 is 1. The square root of 1 is 1, plus 3 is 4. And then we put in a 5. 5 minus 1 is 4. The square root of 4 is 2. And 2 plus 3 is 5. And then lastly, if we put 10 in, 10 minus 1 is 9. The square root of 9 is 3 plus 3 is 6. And we will plot our points. 1, 3, 2, 4, 5, 5, and 10, 6. There's our points. And we can draw our curve from that 1, 3. That is the point we start with, because we know if we take anything that was, again, anything less than 1, 0 or lower, whatever, or even a decimal that's less than 1, will give us a negative under the square root. So we know our domain, our x values, are restricted to anything positive after the number 1. So there is our curve for y equals the square root of x minus 1 plus 3. Okay, one last example. This one I want to point out, we have y equals the square root of x plus 2 minus 1. And I want to point out, you might be thinking, wait, I thought she said we couldn't have negative numbers for x. Notice I did not ever say that. What I said was we can't have a negative under the square root. Now, if I put negative 2 in here, what do I get? Negative 2 for x right here, negative 2 plus 2. Well, negative 2 plus 2 is 0. This will become 0. The square root of 0 is 0. And then 0 minus 1 is negative 1. Again, if I were you, I'd pause the video, give these a try, and then come back and check to see how you're doing. All right, if we put negative 1 in here, negative 1 plus 2, well, that'll be 1. The square root of 1 is 1 minus 1. So we've got 1 minus 1, which is 0. Now, if we put in a 2, 2 plus 2 is 4. The square root of 4 is 2. Then we have 2 minus 1, and that is 1. Lastly, we'll put in a 7. 7 plus 2 is 9. The square root of 9 is 3. 3 minus 1 is 2. All right, let's plot these points. We have negative 2, negative 1. Then we have negative 1, 0, 2, 1, and 7, 2. All right. Our curve starts at this value right here. It couldn't be anything less for x. And there is our curve for this square root function.